Welcome to lesson 3 in the mini holiday course, whatever you want to call it. We're just looking at finance and the syllabus dot points for finance in Maths Advanced course. Okay, so today it's lesson 3. We're looking at annuities and tables of future value. So let's get started. Alright, so syllabus dot points use a table of future value interest factors to perform annuity calculations, and there's an example. They've given 3 different types. I'll try and cover all 3 today. So my interpretation is fairly self-explanatory. You have to learn how to use a table of future value interest factors, which looks something like this. That's a table of future values of a $1 annuity, and I'll explain that in a second. Now there's one interesting here though. If you look over here, this sentence, the single sum that would produce the same future value as a given annuity. That is just the definition of the present value of an annuity, and it doesn't actually mention the word present value in this particular dot point, but I believe the present value, the words present value are mentioned in the other dot points. So just be aware of what a present value of an annuity is, and we will cover it today because obviously this is explicitly stated in this particular dot point. So we are going to do it. Alright, let's just get started. So here's a sample table. Now, what does this table actually mean? What does it tell us? Well, it tells us that if you invested $1 as an annuity, which, if you remember from the previous lesson, means that you're depositing $1 at regular intervals. You're depositing $1 at regular intervals at a certain interest rate for a certain number of time periods. And I've just gone up to 12, just because this is just an example, right? So how much will you end up having? What will be the total future value of the annuity? If you were to deposit $1 regularly, this is an annuity, it's not compound interest, it's an annuity, right? We're depositing $1 regularly, and all of those investments will earn interest over time, so to speak. Okay, so what would it be worth? This table really simplifies the task. For example, if you were getting charged an interest rate of 6% per time period, and you invested the $1 as an annuity, you deposit $1 regularly for 5 time periods, right? So I'll use a highlighter so it's easy. 6% is the interest rate, and you're depositing, and you make, 5 different time periods, you're making $1 deposits and so on. How much will it be worth? Well, the way it works is $1, an annuity of $1, regular deposits of $1 at 6% per annum per time period for 5 time periods will be worth $5.63. Now, obviously, there's 4 decimals given. The reason it's given to 4 decimals is because we're not really interested in the $1 per se. We're more worried about, we're more concerned about if you deposit $500 as an annuity. So every single time period depositing $500. So the way you calculate the $500 is, well, you have 500 of these $1 annuities. So really, you can just do 500 multiplied by 5.6371, and that will give you what we're after. If you had an annuity, you're making deposits of $500 regularly at 6% per time period for 5 time periods. It'd be 500 multiplied by 5.6371, and our annuity would be worth $2,818. Okay, I'll do one more example. Let's say, for example, you are depositing, I don't know, how much. Let's say, for example, typical person, let me just think about it. How much can they deposit? Let's make up a number, roughly $2,000 a month. Let's say you're depositing $2,000 a month, okay? If you deposit $2,000 a month for a year, like 12 months, right? How much will your annuity be worth? And your interest rate is, let's say, 7%. Well, 7% is our interest, so we just go down over here, and we're doing it for 12 months for a year. So really, we're concerned about 17.8885. So how much will you have? Well, it's $2,000 multiplied by 17.8885, and you'll end up having $35,777. So if I were to write a random equation. So the future value of an annuity is equal to, so what do you call this? What do we call this? Interest factor. So we'll just do interest. You know what, I'll call IF. IF for interest factor multiplied by your regular deposit or annuity deposit. I don't know what do you want to call it, right? It's the amount that you're depositing on a regular basis. So I'll call it D. I'll call it RD for regular deposits. So that's kind of like the equation. I can't totally remember. I'm sure there's like a proper one. It's not coming to my mind at the moment. Future value. To use this table, the future value of an annuity is equal to the interest factor that you find in the table multiplied by the regular deposits you're making. So yeah, let's just look at a question. Okay, so a certain grammar school in Sydney has yearly school fees of $40,000. Upon the birth of their child, certain enterprising couple figure that if they have $250,000 in exactly 11 years' time, then this sum should fund their child attending this school for grades 7 to 12. If the couple start an investment account where they deposit $10,000 every year. Okay, so that's another thing. Many students, in my experience, my students anyway, they really struggle with compound interest and annuities because they can't tell when it's a compound interest question and when it's an annuities question. Well, the key is they're depositing $10,000 every year. It's regular scheduled deposits. It's not that they're not depositing once. If they were depositing once, it would be a compound interest question. But because they're making regular deposits, right, that is the hallmark of an annuity. That's the distinguishing feature. You're making regular deposits, multiple deposits. Okay, so they're depositing $10,000 every year. That means it's an annuity. That should tell you straight away this is an annuity. Okay, at an interest rate of 8% per annum, will they have enough in 11 years' time? So we're going to use the table now. So let's just see. Now it does say that it's 8% per annum. So straight away we know it's 8%. Now sometimes you will have compounding period given to you. Just make sure you convert the interest rate to match the compounding period, and you also convert this n, this 11 years time, to match the compounding period as well. So if they were, for example, give us 8% per annum, but it's compounding quarterly, we would divide the 8 by 4, and you would be looking at this column. So it really depends on the question. Make sure you always in all of finance questions, any finance question you do, the first thing you do is you make sure that your interest rate and your n value, your time value, matches the compounding period. Convert it, change it. So the 11, you do 11 divided by 4, the 8% you do 11 divided by 4, if it was compounding quarterly. Now in this question, it doesn't say anything about that, so we're just going to stick with 8%. We're just going to assume, or rather that's what it's saying, right? 8% per annum per year in 11 years time. So we're assuming it's compounding per year. So let's just go with that. So it's 8%. 11 years time, so it's 11 time periods. Okay, so we are dealing with where they intersect 16.6455. And they're doing $10,000 every single year. And so we just pull out our calculator and we say $10,000 every year. So we'll do 10,000 multiplied by 16.6455. Will they have enough? No, they will not have enough. Because they will only have $166,455. So will they have enough? No, they will not. No, they won't. Okay. Moving on to the next type of question. So that's the first type. It's where you calculate the future value of an annuity. So we calculate the future value of this annuity if they deposit $10,000 every year at 8% per annum for 11 years. What will it be worth? Well, it will be worth $166,000. Okay. I can't be bothered writing a capture screen. That's how much they will have. So that's not $250,000. They needed $250,000. All right. What about a different type of question? So this is mentioned first. Sorry, I'm kind of jumping back and forth. The first one was calculating the future value of an annuity. We've done that. We've knocked that off. What about the next one? The contribution amount required to achieve a given future value. So let's have a look at a sample question. The contribution amount required to achieve a given future value. Question 6. It's just continuation of the previous question. How much must the couple deposit each year in order to have $250,000 in 11 years' time? Well, oops. So we look over here, and we're just going to be basically a different value is missing. Instead of regular deposits, now we need to find the regular deposits, but our future value is given, right? So I will, you know what, I'll copy this down and just leave it over there, and we will do our work. So future value, how much do they need? They need 250,000 is equal to the interest factor. Well, the interest rate hasn't changed, presumably. I should have made it more obvious when I was writing the question, but the interest rate is still 8% per annum, and it's still going to be 11 years' time. So we're still dealing with 16.6455. So we're going to write over here 16.6455 multiplied by regular deposits. Well, that's what they're asking. How much must the couple deposit each year? What is our regular deposit going to equal to? Well, we have this equation. It's just straight algebra. Divide both sides by 16.6455, and we should have our answer. So fairly straightforward. Divided by 16.6455, and we get $15,019 roughly. So 15,019, 019 point, what was it? 07. Okay, is equal to the regular deposit that must be made. And so how much must the couple deposit each year? $15,019 roughly, in order to have $250,000 in 11 years' time. Done. Now it says, now we get to the interesting question. The couple want to investigate their options. So instead of an annuity, maybe they're thinking of depositing one single sum. They want to explore the option of investing a single lump sum, which would be the equivalent of a $15,000 per annum annuity at a rate of 8% per annum for 11 years. Now, once again, think about it, right? An annuity is multiple deposits. What do we call it when you have a single deposit? When you have a single lump sum deposit, what is that? That's a compound interest question. A single lump sum. So they're investigating their options. What would a single lump sum be worth now? So future value has to equal to the present value, 1 plus r all to the n. Okay, that is the compound interest formula. That's what it's asking us. So they want to explore the option of investing a single lump sum now, which would be the equivalent of a $15,000 per annum annuity at a rate of 8% per annum for 11 years. So 8% 11 years, 8% 11 years, 16.6455 still. So we have 16.6455, and you're investing $15,000 per time period, or per year. So how much will we have? We'll have 16.6455 multiplied by 15,000. So our annuity is going to be worth that much. That's how much our annuity is worth, right? 249,000 roughly. Now the question is asking, how much can we deposit now? A single lump sum, one amount, a single lump sum, one amount, one deposit only right now, which would be the equivalent of, would be exactly the same as that future value of that annuity. So what do we want our future value to be? 249,682.50 has to equal to the present value, the current investment, the value we're going to invest now. Okay, 1 plus, what is the interest rate? It's 8% per year, so 8 over 100, all to the power of 11. Okay, so we want to find the present value. It really is just a compound interest question. This is the present value of an annuity. The present value of an annuity. Okay, let's just do it. Okay, so what's the present value going to equal to? Present value is going to equal to, now it's just a calculator question. We will divide both sides by this amount to isolate PV. We want to make PV the subject, present value the subject. It's just a compound interest question. Have a look at lesson 1 if you need to brush up or revise or whatever. So 249,682.50 divided by, it's going to be 1.08 to the power of 11. And once again, if you're not sure how I got 1.08, it's just 1 plus 8 over 100. You want to calculate, you'll see it's 1.08. And so there we go, 107, 84. 107, 804.17. Oops. 107,084.54. That's the present value, the single sum equivalent of the annuity. You can deposit this much right now and it'll compound to give you 249,000. Or you can have an annuity where you deposit $15,000 per year for 11 years and you'll also get 249,000. So this is kind of like a mix of annuities and compound interest. So a very juicy question. The HSC generally, this is my experience, just my my perception of it. The HSC questions, they try and examine as many different areas of the syllabus as possible with a single question, because they want to try and examine you on as much as possible in the 3-hour exam that they have. And the only way that's possible, because you study so many topics, the only way that's possible is if if every question tries to cover as many topics as possible. So this would be a very good question. Anyway, so that's it for today. Now the homework, quote unquote, is as you see on the board. Once again, I looked at Cambridge textbook Maths and Focus and the Fitzpatrick, and I like the Fitzpatrick questions this time. So the questions are listed. If you don't have the Fitzpatrick textbook, that's okay. Don't do the Cambridge textbook because it doesn't really have this topic. I'm not really sure why. At least I couldn't find it. I'm sure it has in like an investigation section or whatever. But anyway, you can do the Maths and Focus one if you have that textbook, or the Fitzpatrick one if you have that textbook. Best of luck, and ask for help on Discord if needed.